So we'll start the lesson. Okay. So we have different types of tool holders. Yesterday we were discussing, and the tool holders is one of the important attachment of the lathe machine, and these are different tool holders. Yesterday we have discussed some, and today we'll discuss some of them. The straight tool holder is one of them. Plain or adjustable angle cutter holder, offset cutter holder, and combination cutter holder. So people are joining late, that's the problem. Ajad? Ajad?
Sir, yes, sir.
I'll make you co-host. You try, like yesterday, you try to go for that, this one.
Okay, sir.
I don't know, Srinivas sir has joined. Okay, I make you the co-host and you allow the particular people. Okay?
Okay, sir. Okay.
So we'll start the lesson and you try to see the recording is going on or not. Okay? Try to tell me. Recording avutundamma?
Yes, sir.
Okay, okay. So the first one, we have the straight cutter holder, and you can see the figure. It is a simple type of holder. It's used to hold the standard type of tool bits, and just try to go there. Okay. So the particular, we have a tool holder, we have the tool, and this is a workpiece, and it is a mostly the holder shank. This is the shank is directly mounted in the hole. The shank is directly mounted in the hole, and of the multiple turning head. We have different multiple turning heads, but here we will use only one type because in the turning centers we'll try to use more of them. So the tool is in this holder is held perpendicularly. You can see it is held perpendicular to the shank axis. This is the shank axis, and it is held perpendicular to the particular shank axis and gripped by 3 set of screws. These are the 3 set of screws showing in the figure, and the various operations performed by holding the suitable tool in the holder are turning. So what are the operations can you perform? Are turning, facing, boring, counter boring. After boring, you try to go for counter boring up to a certain depth of that particular hole or already the bored hole. So chamfering, etc. So chamfering is an important part in order to reduce the sharp edges. So you might have seen all that in the this one in the practical in the machine shop, and you have the lab also. You can know very well. So in this type of the second one is the plain or adjustable angle cutter holder. Plain or adjustable angle cutter holder. So in this type of tool holder, you can see the tool is held at an angle. So which is provided in the body of the holder. This is provided in the body of the holder. This is a micrometer screw. So to have that particular tool at a particular angle, so the tool is held at an angle and used for turning operations. And boring operations are very close to the jaw chucks. So boring operations have to be performed very close to the jaw chucks. So the angle of the tool, how you can adjust by adjusting the set screw, by adjusting the micrometer screw. So micrometer screw is provided on the tool holder. Other tool holders, you don't have the micrometer screw because in this particular adjustable angle cutter holder, you have to provide that particular tool at a particular angle. So this is a very important and very important type of tool holder where you want to have the particular operations at a particular angle, machining operations at a particular angle. The other one is you just try to see the diagrams. This is a step, and this is the workpiece. This is the job, and the tool holder. This is a tool, and these are set screws. Every time you don't have to tell these are the set screws because how you fix the particular tool on the body of the tool holder. So if you want to have an angular slots or angular grooves or any other operations, you have to have that particular angular plane or angular cutter tool holder. So what is the offset cutter holder? Offset cutter holder is one of the particular holders in which we try to provide the tool at a particular offset. Offset means not exactly. You just try to see this particular. This is the axis. This is the tool. This is the job axis, and you try to have that particular offset. This is offset. The particular thing I'm showing by the arrow is offset. The tool offset. How you can anybody can tell how you can determine the tool offset. How you calculate the tool offset. Tool offset is nothing but you have to take half of the diameter of the cutter or half of the diameter of the tool. Suppose the diameter of the tool is 1 mm, you try to take the offset as 0.5 mm. So that is very much important because already I told you tool compensation and tool offset are very important terms in the computer aided manufacturing. And the particular we have the angular offsets, so the particular offsets also can be made with the offset cutter holder. If it is we just try to want a particular offset for the particular job or workpiece or the as per the design. And the tool compensation, just I'm telling, we have the left hand tool compensation and right hand tool compensation. We have some G codes related to that particular compensation in the CNC programming. Just like a fan switch or a light switch, you have to activate that compensation, the tool compensation. Like in a CNC control machine, CNC computer numerical control lathe or some other machining center, you have to write this G codes. G40, you have to activate that particular tool compensation. G41 for left hand tool compensation, or it is also known as cutter radius compensation. G42 is the right hand tool compensation. So like that, we'll try to discuss in the advanced subjects all this one. But as of now, what is tool offset? Already I told you, you have to take the half the diameter of the cutter. This is the tool holder, and this is the tool. We have the set screws. This is the workpiece where we have to go for the offset. So in this type of tool holder, the holder body is inclined offset with the shank axis. This is the shank axis. So it is held at an offset. So you have to calculate that offset and try to turn the tool with that particular value. So here it is used to turn or bore large diameter workpieces. And you have to use design what is your requirement. So next one, it is a combination tool holder. Combination tool holder is nothing but you have to. Ajad, can you hear me? Ajad?
Sir, yes, sir.
Okay. Sometimes internet connection is unstable. I'll be asking at that time. So in order to perform various turning and boring operations, all this particular combination tool holders are used. So this is a combination tool holder, and it is used for holding multiple where you are using multiple tooling heads for using a number of tools like the boring or the turning tools, or you can have not only boring, you have the drilling and reaming operations also. So it's not exactly like in the textbook. It's a combination of operations like yesterday we have discussed. So this tool holder is used for performing a number of simultaneous operations effectively. So that is the very important feature of this one. And the tools are aligned at different positions. You can see tools are this is a one head, one turning head. This is one turning head. So whenever you try to finish a particular operation at, suppose you try to finish a turning operation at this particular turning head, you can switch over to the another turning head. That's why in a combination tool holder, you can perform operations not simultaneously one by one, because sometimes whatever the words you are using, you have to be very careful. So, but you have to design the whatever you have to make the tools in your tool room, or if the particular tools are not available in the tool room, you have to procure from the tool room manufacturer. So that is very important. And here the particular the tools are aligned at different positions by inserting shanks of tools in different holes of tool holders. Here you have the holes, and how you hold the tool by means of set screws. By means of set screws, you have to hold the tools rigidly by tightening the set screws. This is very important aspect of the combination tool holder. So next we'll try to switch over to the. So what are the different types of tool posts? We just try to discuss now. Tool holding devices we have finished, and whatever things we have not discussed, as far as today we'll try to finish off all the things related to topics related to tool holders, and slowly we'll go for the introduction of the turret lathe and capsule lathe. In one of the PDFs, you have to share another PDF. So the particular this one, the tool post is generally used for the purpose of holding the tool. You know what is the tool post? Because already we have seen in the general lathes or the engine lathes or the all gear head lathes or different lathes are there in the particular machine shop, you'll be having that. So it is imparting a rigid support and during the machining. So what are the different types of tool posts? So one is the American type single tool post. You try to see this is a mostly it is a simple tool post, or it is also known as the American type of single tool post. You try to see the tool post where the cutting tool is held by means of a bolt or a set screw at the top, and this is the rocket arrangement. You can this is the flange of the particular tool post, and this particular single tool, only a single point cutting tool can be held in the tool post. Only a single tool. I already told you what is the difference between a single tool post and a turret, hexagonal turret, an octagonal turret, or a disc turret, which can handle up to 14 tools. So in this, the tool height, you have to adjust the tool height. Why we have to adjust the tool height? Because you have to see that it is exactly aligned with the job, aligned with the center of the job. So that particular tool height is very important adjustment by the machine operator. So how you adjust the tool height? By tilting this rocket arrangement or rocker. Actually, it is rocker, not rocket. The spelling mistake is there. It is a rocker arrangement. So it causes a change in the rake and clearance angles of the cutting tool. So by arranging this, you can have that particular already the rake and clearance angles of the cutting tool are made in the tool room, and you have to, and the tool room inspector has to check whether the particular nomenclature is there as for the single point cutting tool. Already you have finished in unit 1 that one. So the body, what is the body? The body comprises of a slot, so in which the tool shank can be accommodated. So this body, you have a slot in which the tool shank is accommodated, that is a single point cutting tool can be accommodated. So where do you use this type of particular American type of single tool post? This you try to use for light duty applications, not heavy duty applications. So heavy duty tool holders are also there. There you try to use the particular the heavy duty tool post. So the second one is the open side tool post. You try to see that in the figure, you have an open side tool post. This is open. This is open. So you just try to see. We have a knee type of tool holder or tool post where the clamping bolt is there. This is the set screw. You have to differentiate between the bolt and the set screw. So here you have the adjusting screws, one at the left and one at a distance from the left hand, and you have two types of, and this is the open type of side tool post. It consists of a clamping bolt which is used for mounting the tool post. You have to mount this tool post on the where you mount the tool post on the cross slide. So just try to see. So the adjusting screws, these are the adjusting screws. It just helps in holding and positioning the tool according to the requirement. According to the requirement. So all these are very important aspects of the particular thing, and you have to use the packing material. You have to use the packing material under the tool. So sometimes what is the packing material? You may be saying only small flat mild steel pieces. They are known as shims actually, SHIM. In the industry, we used to name them as shim because it is a traditional way the production engineers try to make the shim and on the surface grinding machine that according to the particular thickness 0.5 mm, 0.25 mm, not more than 1 mm. Actually, shim is a small, slender mild steel sheet, just like this GI sheet. We just try to make it and try to adjust the tool height. So it can also be employed. This open side open side tool post can be employed as a rear tool post, because we can have two tool posts, one at the front and one at the back, because in the machining centers we have in the turning centers we try to adopt the two tool posts. Suppose the machining operations, are finished on the front tool post, we'll try to change over to the rear tool post. This is known as shuttling. From one tool post to the other. Actually, in the features of the machining center, we will be discussing all this particular whatever we are performing as far as the on the machine, the operations, the machine setting, and sometimes we can name them as pallet shuttle. That is a difficult keyword for you to understand at this particular stage, but we are just telling you have known the literal meaning of shuttling from RR pad to college and from college to your particular house. So that is very important, shuttle. So the square tool post, it is a common design which is employed for most of the lathes, the engine lathes, because it is used for square tool post or turret tool post in case of the turret lathe. So it is used for the mass production. So it carries, you just try to see, four different tools at a time, because it is very important, because you can, why is it designed or designated for mass production? Because the machine setting or the tool setting can be done at a time for a given operation. So this tools can be in position. So it can be in position. This is one particular tool, this is one particular tool, this is one particular tool, and you fix the tool by means of set screws. So this particular tools, whatever we are taking, they can be positioned instantly for performing the desired operation. So you have to have the adjusting handle or the particular handle to position the tool instantaneously or instantly at a particular place to perform the particular operation, turning operation or the facing operation or the drilling operation, different operations. So what is the time required for setting different tools? So what is the advantage of the particular square tool post or the American type or the open side tool post? Because we can reduce the machine setting time. The machine setting time can be reduced drastically, reduced drastically, because we are setting different tools for different operations to be performed on a particular workpiece or a job simultaneously. So whenever that particular operation has been finished, you try to position the next tool, or you try to place the next tool in front of the job or workpiece. That is the advantage of this square tool post or the turret tool post. It is very important that you try to have this particular thing. This is also very important as for the examination type of concern, the work holding devices, the tool holding devices, and the tool post. So the quick release. So it is a quick change tooling. Quick release type of tool post is used in quick changing of the particular tools. So it is mostly used to accommodate whatever number of tools are there. Actually, in the machining center, another feature I want to tell, it is a particular tool in which you can have a preset large number of tools in the tool magazine. It's a storage of the tools. Why the word magazine has come in the .22 or the .303 rifles, with the use in army or navy? They try to have that particular magazines, the particular bullets that has to be loaded in that particular gun. The ordinary gun we have 6 bullets, but in the other types, just like the tool magazine can accommodate, the theoretical limit is 48, 54, and 60. So if you have a single row, suppose you have a double row, we have different types of tool magazines. We will try to discuss later. Double row means we can have another type of expandable type of tool magazine. It can accommodate another row. So we have the chain type of tool magazine. We'll try to discuss in the CAM subject. So that is a very manufacturing is a very interesting subject, because for automation, because the particular country's economy will depend on the hands of the manufacturing people. The design people are also very important because without designing, you don't go for manufacturing. That's why some of the terms like design for manufacturing is very important. So this is a quick change tool post or the quick release type of tool post in which have number of tools are there. You can accommodate number of tools. The adjustment of the tool also can be accomplished or achieved quickly because by means of screw mechanism, you don't have to have the shims or the metal pieces under the tool post, and by the screw mechanism easily you can adjust the tool height relative to the center of the job axis. So that is very important, and also the tools can be preset, so you at the desired height. That's why we can reduce the particular machining time, just like the square tool post. Square tool post, because you can reduce, you can set the tool height for a particular tool beforehand, just like that. So it eliminates the need of adjusting the tool repeatedly. Whatever tools, suppose you have 6 tools, all the 6 tool heights can be adjusted prior to the machining operation. Prior, because the machine operator is having a particular advantage of using this quick release type tool part or tool post. So it is a quick change tooling. In computer aided manufacturing, it is known as quick change tooling. So that is very important, and it is a quick release type of tool post, which is very advantageous when compared to the other type, the other tool post. That is very important because you have to see that. So we'll just switch over to the particular things we have not covered yesterday. Another new share, we'll just try to go for that.
Sir,
హలో
what happened? Sir, screen off అయింది సార్ అందుకే.
నేను కొత్తది చూస్తున్నానమ్మా.
Okay, okay, sir.
So I want to just observe. Now you can see.
Sir.
You can see the screen. Okay. So some of you have to mute your thing. Some disturbances coming. So this is a particular example I just try to tell. We'll just try to switch over because I want to just remembered I have to show this super quick change tool post how it is because we can add more adjectives, but mostly it is a quick change tool post or a quick release tool post, and it is very important that you try to have this because somehow some designs take it patent. You don't have, because if you take a patent, the other person should not copy this particular design. That's very important, and the engineers because I want to wish on this Engineers Day, very happy Engineers Day to all. I forgot because we will be lot of internet problems or other problems are there. We have some particular tension, not like offline classes because all depends on the power and the internet stability. So this is a patent locking system in which you have the sliding. This is known as the sliding gib, and this is the locking pin. And we have to push to release the tool. You have to push this to release the tool, and you have to pull this to lock the tool. So suppose you want to lock the tool at a particular position relative to the job axis or relative to the job, you have to use this this quick change tool post. And this is the locking handle safety stop. Why we have to go for the locking handle safety stop? Because suppose you are not locking the tool properly, or during the running time, the tool, if it gets loosed or released, there's a chance of hurting the operator. It is used for safety operations, like the emergency stop in a CNC trainer lathe, or an emergency stop in case of a machining center, or an emergency stop in case of a turning center. There are different centers like machining center, turning center. Even we have a milling center. Unlike the milling machine, all this are costing lakhs of rupees, because in order to enhance the productivity in a flexible manufacturing system, we have to use different types of centers. So that is very important. So next we have to go for the next topic. We just try to see. So we have that particular again we'll try to switch over to the particular things where we try to finish off what are there in that particular slide, or we just try to go to that particular, we'll just come back to that whatever things are there. Yesterday, we have finished everything as related to this one, I think. So we have, as for the face plates are concerned, we just try to see, have a quick look at this one, large slotted face plate. This is small slotted face plate. This is a driving face plate. So we'll just try to finish this also, because some of the diagrams are there, not there in the earlier PDFs. Yesterday we have spoken of the male center, the different types of centers. This is the half male center. This is the female center. Just try to see. This is the V center. So this is the ball bearing live center. Ball bearing live center is used only at the headstock center. The pipe center for use for the cutting of the long pipes, and the self-driving center, just like the particular revolving center, which is used only at the particular heads, the tailstock side. All lathe dogs we have discussed yesterday, but you have to see the mandrels also. Yesterday we have seen the different mandrels, the solid machine mandrel, the expansion mandrel, all this. So we have the steady rest and the follower rest. So all these are very important parts we have to discuss. That's why after at this weekend or today, if it's possible, or tomorrow, I'll share all these particular things as far as the unit 2 is concerned. You just try to see in the, what is the, anybody can ask, what is the, so we have a carriage stop. This is a micrometer carriage stop, because the carriage has to stop at a particular position on the lathe machine. So this is the V way, that is the guide way. This is the clamp, this is the spindle, and this is a graduated collar. Graduated means some divisions are there. This is a clamping board. Suppose you want to stop the carriage at a particular place, you have to adjust the micrometer reading and try to stop the particular carriage at a particular position on the lathe machine. Just like for a different alignment test or the acceptance test, you have to keep the saddle in the mid position of the lathe bed. Suppose the lathe bed is 5 meters, you have to go for 2.5. Just giving an example, 5 meters of 5,000 mm. So this is the steady rest yesterday, and the
Sir.
Ajad, try to unmute, mute them. So this is the steady rest and the follower rest. Yesterday we have seen.
So screen not visible, sir.
Screen, oh.
Yes, sir. Yes, sir.
అయ్యా నాకు చెప్పలేదమ్మా.
Sir.
I'm seeing the controls.
Sir, ఇందాక నుంచి చెప్తున్నాను సార్.
Okay. చూస్తా. నేను షేర్ చేశాను అనుకున్నానమ్మా, పర్లేదులే.
ఓకే సార్.
పర్లేదు, ఇప్పుడు ప్రాబ్లం లేదు. ఇప్పుడు all this were taught yesterday, that particular only the revision I am doing now. Okay, so all this we have the particular grinding wheel, that particular I want to tell the particular this one, the tool post grinder. So the tool post grinder is given in one particular figure. We just try to see where we use the tool post grinder, especially designed for the cylindrical grinding operations, because the surface grinding machine is another machine tool, which we will discuss in the unit 4 or unit 5. But this is a completely a different type of tool post grinder. We just try to have that abrasive wheels for internal grinding, and they're fixed in a chuck. So just try to see that particular diagram related to the grinding post. This is the particular tool post grinding machine. Here we have the motor. This is a belt guard. This is a belt where we have to operate the particular grinding. If you want to go for slow grinding or a medium grinding, or because it will affect the surface finish on the job. So this is the wheel guard. This is the grinding wheel. Grinding wheel we just try to discuss, because it is one of the particular grinding operations. We have to have a abrasive type of grinding wheel with different grits. the silicon carbide and other type. This is a clamp, this is a spindle. So this is a tool post grinding machine. So this is one of the, other than the quick chain tool post, you can add this tool post grinding machine also. So in this we have different types of this one. So all these are very important things. So what are the particular, here this particular minerals were discussed in this particular this one. So we'll just try to move to another PDF where we try to have that introduction of the particular, just try to go for the introduction of this particular this one. I'll go for the new share now. So just we'll try to switch over this one. So we will switch over this one, this particular screen. And can you see the screen now, Ajad?
Yes, sir.
Okay. So now we'll go to the introduction of the capsule lathe. Capsule lathe. We have finished that particular all the particular things, and we try to go for this particular capsule lathe. And slowly we'll finish the capsule lathe and turret lathe tomorrow. So tomorrow we'll discuss the capsule and turret lathe. Today we'll go for the introduction of this particular thing, and we'll try to see the differences between the capsule lathe and turret lathe, the differences between the capsule lathe and engine lathe, and everything. So in contrast to the center lathes, so this particular, this center lathe or the engine lathe, this particular lathes are semi-automatic. What are the features? They possess an axially movable indexable turret. So already we have spoken a lot of times, this hexagonal turret, the tailstock is replaced by the hexagonal turret. So here third one, this one, it holds a large number of cutting tools. It holds a large number of cutting tools, up to 4 indexable tool posts on the front slide. So 4 indexable tool posts. So you have to use a square tool post, or you can use that particular the hexagonal turret. So you just try to see, and you can use tool post, 2 tool posts, one on the front tool post and the other on the rear slide. So you can use up to 6 tools in the hexagonal turret, and you will see the diagrams later, but we just try to go for the introduction now. And these are used for more quick engagement and all-out functioning of the tools. So just try to go for quick engagement like the quick change tool post, and they use the tool. The tools are in addition to faster mounting. So you have to feed the job. You have to go for the quick change tool post, and you have to go for the rapid speed change, because the rapid speed change are done by the tumbler gear mechanism. We try to discuss some of the mechanism at the last, because they're very important after the discussion of the caption and turret lathes. So all these are very important. So what is the main feature of the capstan and turret lathes? It enables the repetitive production of the same job, same design or the same job, because it involves a less effort on the part of the operator. The operator has not to do the much work related to the center lathe or the engine lathe, because he'll feel free, or he will not fatigue whatever we say. If you try to operate the capstan and turret lathe, when you try to operate the center lathe or the engine lathe, you'll feel comfort. The comfort level is more. So that is the particular feature. And this particular operator, is presetting of the work speed and feed rate, presetting the parameters of the spindle speed or the cutting speed and the feed rate, and the length of travel of the cutting tools. You will adjust all that particular things beforehand, because it is semi-automatic. The capstan and turret lathes, and compared to the engine lathe and center lathes, are semi-automatic, and they are suitable and economically viable. They are usable for batch production or small lot production, because same jobs, same designs. Same jobs means, suppose you take a bearing, suppose you try to take the gear, you try to take a piston. So all these are the particular things we can manufacture, connecting rod, all the IC engine components. So these are useful for batch production. Just try to see that. So this is a particular diagram related to the capsule lathe. You just try to see what is the capsule lathe. So we have different diagrams. We just try to see, and we'll just try to have that particular diagrams. Just try to see the particular diagram. Okay. So what? So you have, instead of a particular this one, the tailstock, the hexagonal turret, it is replacing the tailstock, and the headstock side is same. You just try to see, and this is the clamping lever, and this is the hand. In the next diagram, because already I told you the speed and the feed mechanisms are previously set by the operator. You don't have to, when the machine setting time is reduced drastically when compared to the center lathe, and that's why the productivity is more. The productivity is more. The same design of job pieces, the same batch of job pieces can be made. That's why it's useful for batch production. So all these are the particular type. This is a tool post, you know. This is a tool post. This is the handle of the tool post. This is the hand wheel to operate the carriage. To operate the carriage. So all these are semi-automatic. The tumbler gear mechanism, whatever mechanisms are there for the change of the spindle speeds can be incorporated at the headstock side, because it is covered. This is a simple diagram anybody can draw as far as a capsule lathe is concerned. You already know the components. The other components we have discussed in a center lathe or engine lathe. The other components are same, except the particular turret, hexagonal turret, which is replacing the tailstock. We don't have the tailstock in the capsule and turret lathe. So just try to see this particular things, and we have all this particular stuff. The hexagonal turret, everything is same. So everybody can ask what is the difference, because some of the guide rods may be missing in the capsule lathe. In the turret lathe, the guide rods are there to guide the particular this one, the particular guideways or the particular job pieces. So all these particular things are very important. The hand wheels, the tumbler gear mechanism, and the feed mechanism, automatic or semi-automatic feed mechanism, everything are there. So just try to concentrate on this particular part also, the capsule and turret lathes, which are very important. This is only introduction. That's why I'm going fast, but you will try to know the differences tomorrow. But you just try to have that particular things as far as the capsule and turret layers are concerned. So you try to draw the particular figures related to this one, and these are very important features which we have discussed. And if anything is there, we'll just try to discuss that also today itself, and we'll try to continue later after the capsule and turret layers. So all these are very important. We just try to scroll and see. So we have finished the taper turning methods, but we have the semi-automatic and automatic lathes also. We have the semi-automatic and automatic lathes also. Semi-automatic and automatic. So what are the general purpose machine tools? Both the fixed automation. So we have in computer-aided manufacturing two keywords, that is the fixed automation or flexible automation. So where the later one, this later one is characterized by this flexible, not or actually and, because flexible automation is where we use the computer numerical control machines, CNC machines, and fixed automation is like the capsule lathes and the turret lathes, where you don't use the programming, CNC part programming, where you don't use the G codes and M codes. So that is the main feature of this particular the particular semi-automatic. So the particular in semi-automatic classification, we have the capsule lathe. Capsule lathe is also known by the other type, ram type turret lathe, because you have a ram which is an overhanging beam. Just like an overhanging beam, we have the ram, heavy duty ram. We have that particular heavy duty ram. That's why it's known as the ram type turret lathe. So we have the ram type turret lathe, ordinary turret lathe. That is some of the particular lathes. The turret lathe is mostly governed by the saddle. We'll just try to see what are the important features of that particular turret lathe also. And we have the multi-spindle turret lathe, in which we have like the multi-spindle automatic lathe. We have the multi-spindle. We can use more than one spindle, 2, 4, 6, 8 spindles. And we have the copying lathe, just like the farm tools we designed for a particular taper turning operation or a taper operation. We try to have the copying. This is a hydraulic actuated lathe. We use the hydraulic cylinders in the copying lathe or the hydraulic lathe. So the classification of the general purpose automatic lathes can be classified as semi-automatic. In semi-automatic, we have the capstan lathe, turret lathe, multi-spindle turret lathe, and the copying lathe. So you have to, already told you, you have to concentrate mostly on the capstan and turret lathe. And in the automatic lathe, we have the automatic cutting off lathe, and we have the single spindle automatic lathe, and the Swiss type of automatic lathe. Swiss type of automatic lathe are also known by the name automatic screw machines. Why they are known as automatic screw machines is that it is mostly designed by the Swiss people, Switzerland people, and apart from the turning and pressing operations, previously in that particular country, they used to turn the screw threads, the particular external screw threads and the internal screw threads, depending upon the, because instead of using the taps and dies, the particular threading tools are designed according to the particular form, that is the external or the internal. That is the Swiss type of automatic lathe. So single spindle and we have multi spindle. Because single spindle we use only a single spindle, but in a multi spindle automatic lathe version we use more than 1, 2, 4, 6, 8. Mostly we use the even numbers because for corresponding, because in a particular lathe what you have observed, for corresponding headstock, for a particular headstock you have the corresponding cross slide. Here in the case of multiple spindle automatic lathes, you have the different cross slides. Suppose 1 to 1. Suppose you number them 1, 2, 3, 4. You have the cross slide 1, cross slide 2, cross slide 3, cross slide 4. So each cross slide has its own action, How the action can be done, how the movement can be done by means of the hydraulic movement or by means of the pneumatic movement or by means of the cam. Cam is a very important word because a cam you use in the machine shop or especially in the automobile manufacturing industry for the particular finish OD turning of a piston, which is the last, which is the which is the second last operation in the piston manufacturing industry. So you just try to learn, because you might have only learned the have knowledge of the center lathe and engine lathe, but you'll be going for the semi-automatic and the fully automatic lathes. So you just try to see all these particular things, and you have to practice these particular diagrams, my dear friends. So suppose you feel comfortable in the particular diagram in a particular textbook, whatever textbooks are specified, you follow that only. The hexagonal turret, here you can see the arrow. The arrow, that is, it is a particular arrow, what direction it is going. It's a clockwise direction. So just try to see. So we have 6 station in which we can accommodate whatever tools we want to perform for that particular job. So that is very important. So you just try to see this particular arrow also, this particular carriage movement or the cross slide movement. All these are very important. This is the carriage movement which is perpendicular to the spindle axis, lathe spindle axis. So this is a tool post. This is whatever tool post you can use, the square tool post or the particular quick chain tool post, but mostly in the capstan and turret lathes, you use the quick chain tool post because you have to reduce the machining time and you have to reduce the tool setting time, and by that you can enhance the you can enhance the productivity of that particular batch production by producing more number of pieces. So all these are very important, the particular capsule lathe and turret lathe, and you have to see what is the feed rod, what is the guide rod. So what are all the components already we have discussed. So this particular capsule and turret lathes are more robust than the center lathe and the engine lathe and the heavy duty machines. You just try to see, and we can machine lengthier work pieces. And you have to, already I told you yesterday, you have seen the collet chuck. You have to use the long, for accommodating the long pieces, you have to use the collets instead of the what? Instead of the 3-jaw universal chuck or the 4-jaw independent chuck. So all this you have to see. So the turret lathes are mostly of the chucking type. So you just try to see. And we have the quick acting chucks also, like the quick acting tool holders, like that we have. And you have to see what is the stroke length, every feature, every important keyword, you have to catch that. So how the turret will travel, how the saddle will travel, how the carriage will travel, how the carriage, you have a carriage top. Actually, it is It is a in the tool grinding machine or the tool grinding tool post or in any other particular tool post. It is governed by the micrometer dial. How much stroke length you have to give for a particular job, or how much the turret travels. So it is limited by the stroke length. So it is like you have to adjust the guide stop. The guide stops are different guide stops because in a machining center they're known as automatic feed stops. But in the capsule and turret lathe, they are semi-automatic. And in the engine lathe or the center lathe, they are manual or semi-automatic. So you have to know where the particular turret will travel, how much it will travel. So where you have to just clamp that the particular turret, hexagonal turret on the main bed. So all that are very important, and all these are very important. We'll just try to discuss. And already I told you the automatic screw machines, the Swiss type of automatic machines. Previously, mostly they have designed these machines as long as 18th century or 17th century, because the designs have been changing all these particular lathes. Don't think only a lathe is used for the metal work or this particular. Some of the wood turning machines, they can be used for wood also or timber also. So suppose in the capsule lathe, the external threads are cut in the capsule lathe. Suppose you have to have some particular opening die, so you have to provide that die for that particular external thread. So you have to know what is the difference between type and die. Every time I'm telling these particular words. So in the turret lathes, these external threads are generally cut by single point or a multi-point cutting tool. Whereas in other type of machining centers, we try to have the thread turning tool to cut the external threads and the internal threads. So all these are very important features. The differences also you should know. The differences also you should know. And already I told you, we have the RAM type. We'll just try to discuss all this tomorrow. This is the RAM, heavy duty RAM. It is almost hexagonal turret. This is and we have the feed stop rods. So just like the guide stop, we have the feed stop rods to just regulate the feed. And this is the lathe bed, and this is the hand wheel for the ram movement, and this is the saddle clamp, the bed. All this will just again come one by one slowly. Just what we will be discussing tomorrow, because I already told you this is an introduction class related to capsule and turret lathe. So all this you have to know what is the type of the capsule lathe and the saddle type of turret lathe. Saddle type of turret lathe, in which we have the hexagonal turret, you have the turret saddle, you have the bed, and this is the hand wheel for the saddle. Keep the saddle in a particular position relative to which tool you are using. In the hexagonal turret, nearer to the job. So all this, the tool heights and everything are not there. Automatic tool adjustments are made or semi-automatic. You can say semi-automatic also. So if it is automatic, slowly it will go to the computer numerical control machines, where you have to adjust the tool offset in that particular x-axis, in the y-axis and the z-axis by means of the control unit. You have the control unit offset, and whatever calculations you are making as far as a particular tool is concerned, you have to compare with that machine tool offset or the control unit offset. Only if it matches, or if it is only a small error, their error will be compensated by the particular error compensator or the particular position compensator as far as the tool position is concerned, or the velocity control or the speed control. So all the controls are there where you will be learning in the control systems, the closed loop control systems, as far as the CNC control lathe is concerned. So we'll stop at this particular thing. So tomorrow we'll start with the particular capsule lathe and turret lathe, and slowly after going for the diagrams and the features, we'll be knowing the difference between the capsule lathe and the turret lathe. That is very important. Okay, you can leave.
ఓకే సార్, థ్యాంక్ యూ సార్.
Okay.
స్టాఫ్ మెంబర్ ఎవరు జాయిన్ అయినట్టున్నారు సార్, సిఆర్ రెడ్డి అని ఉంది.
తెలియదమ్మా ఎవరైనా అది.